All right, I'm going to show you how to conduct a t-test in Google Sheets. I will also show you how to insert the average and the standard deviation. This is probably the easiest way to do this. If you definitely need to use a graph or insert a graph for a lab report. And if you are missing or do not have a calculator, you still are able to compute your statistical test. So what we're looking at right now is made up data of heart rate change. We have several different test subjects. We have their resting heart rate, and then we have their heart rate after walking for a certain amount of time, and then after completing push-ups. Columns D and E tells you their change in heart rate from resting to walking. So it's a simple subtraction of 68 to 65, which is 3. And then in your push-ups, it's 85 minus 65, which is 20. So what we want to find out is the average of these two columns to see if there's a significant difference between, the heart rate change of walking and push-ups. So first and foremost, we're going to find the average. I already titled my cells, and it's just, that is mainly for me to keep my thoughts clear. So for the first average, what you want to do is when you're computing is there is a shortcut. I believe sometimes you have your summation buttons and an average button up here at the top, but I do not have that. I am trained with Excel, and this is very similar. So you're going to enter your equals, and then you will hit you can just type in average, which will come up here, and then you'll have this equals average, and it's going to want to know what are the cells that are you averaging. And in this case, we're doing column D, cells 2 through 16. So you highlight that, and you click enter, and it does the average for you. And then we do the same thing over here. We type in equals, and then your average, and then we're doing E2 through 16, and then we get an average. Now we're going to do standard deviation, and it's the same thing. We hit equals, and then we should get a standard deviation, and we are doing the same thing, D2 to 16, and that will give us a standard deviation for the change in heart rate in walking. And then we're going to do standard deviation for the push-ups, so equals, and then your standard deviation. And we select, and we hit enter. And so now we have our two averages and our two standard deviations, which you may or may not need, but if you're doing a sample problem, you can just have that calculated out for you. Now we have the t-test, and so we have the t-test written over here. And you're going to go up here into insert, you will go to function, and then once you get to function, you'll go over to statistical, and then here you'll go to t-test. And then you'll have the same type of formatting that we use for average and standard deviation. You'll have your equal sign and t-test, and now we have to enter what we want to test. And we are comparing the two groups of the change in heart rate in walking and the change in heart rate after doing or completing push-ups. So we select the data set that we want to do, and the first one is walking, so it's D2 through D16. And then we come up here to the function tab or the row, and we click next to the last cell, which is D16, and we insert a column because we want to have the second set of data, which is your change in push-ups, and we select that column. And now we have the two groups that we are comparing. Now we need to determine the number of tails that we're using, and then if we're using an unpaired or paired t-test. And so now you have to insert another column, and we are going to be doing a two-tailed t-test. So you're going to enter 2. And basically, a one-tailed test, just to kind of give you a little bit of background and some clarification on if you use a one or two-tailed. A one-tailed test allows you to determine if one mean is greater or less than another mean, but it doesn't tell you both. So you must choose a direction prior to testing. So, ladies and gentlemen, in other words, a one-tailed test tells you the effect of a change in one direction, but not the other. So I want you to think of it this way. If you're trying to decide if you should buy a brand name product or a generic product, so let's go back to the drugs, back to our Viagra example. If you're trying to determine if you want to buy the generic or the name brand, a one-tailed test will tell you the effectiveness of the it would only tell you the effectiveness of the product. It would only tell you if the generic product worked better than the brand name. You would have no insight into whether if the product was the same or if it was worse. So it only tells you in the one direction. A two-tailed test, which is what we are going to be using, allows you to determine if two means are different from one another, and a direction does not have to be specified prior to testing. So a two-tailed test will take into account the possibility of both a positive and a negative effect. So if you're going back to the drugstore, if you were to do a two-tailed test of generic versus brand name, you would have insight into whether if the effectiveness of the product was the same or worse than the brand name product. Okay, so you're gonna have both sides. It's a two-tailed test. And then finally, after you going back to how we do this on the on Excel, or excuse me, on Google Sheets, you're now going to have to insert one more thing. So you have your two data sets, the change in walking, which is D2 through D16, the change after push-ups, which is E2 through E16, comma 2, a two paired t-test, and then you hit comma, and then you hit 1, and a 1, there's 1, 2, or 3, and a 1 equates for a paired sample t-test, and this is a way to determine if the mean, if there's a statistical difference between two sets of observations. So this is what you'll be entering. So you're always going to enter a 2 and a 1 if you're doing a t-test of two-tailed of paired data. And now at this point, you should be able to enter it, and you should be able to have your t-test value. And that is how you complete a t-test on Google Sheets.